So I want to run through a problem of an inclined plane with friction. So this one's going to be a little different because we're going to pull up the box with friction. So as with every problem, we start by drawing a picture. And labeling our forces. But now I'm going to pull up the box with an applied force. And there's also going to be friction. You can draw in the angle here. It's the same angle as our inclined plane. Next, we have to write our F net x and our F net y equations. What you want to do is take a look at your picture and you want to ask yourself what forces are acting in the x direction. You can see that as I extend the x-axis here and the y-axis here, the applied force and the friction are only in the x direction, where part of the weight is in the x direction. And we know that as our mg sine of theta. The next step is to assign pluses and minuses. We are going to pull this block up the incline. So we're going to accelerate up the incline. So I'm going to call that positive. That means Fa minus friction minus mg sine theta is going to equal 0. In the y direction, we look at the normal force. And since I have an mg sine theta in the x, I have to have the equivalent component in the y, which is cosine. They're opposite each other, and we're not accelerating. Oh, I'm sorry, going back to this one. It is accelerating, so ma. So again, let's just recap what I did. I looked in the x direction, and I saw that Fa and F were only in the x direction, as you can see here that I'm highlighting. And this part of FGX is also in the x direction. Now, I'm going to solve for the normal force. So N equals mg cosine of theta. We're going to put some easy numbers in here. 10 kilograms, 9.8 cosine of 30 degrees. That's going to equal 84.9 newtons. We're going to give this ramp a coefficient of kinetic friction of 0.3. Now we are going to solve for acceleration. Let's say we are going to pull the ramp up with a force of 175 newtons minus our frictional force, which is equal to mu kn minus mg sine theta equals ma. So now if we go through and plug in our values, mu k is 0.3. Our normal force we calculated to be 84.9 minus 10 times 9.8 times the sine of 30 equals 10 times A. So what we get is a total net force of 100.53 equals 10 times A. So then A is going to equal 10.05 meters per second squared. That's a very large acceleration, so clearly these numbers are a little skewed, but the process is the same. Draw in your forces, write the F net x and the F net y equations, solve for normal force, and then continue to solve for your acceleration. I hope this helps.